Alright guys, so some of you were asking about some gear problems, so I decided to take some time and go through some gear problems for you so you can kind of see, you can have something to study on. Alright, so gears as just a quick recap. A gear is gear train, so this would be what we consider a simple gear train because there are two gears that touch each other and they mate, so the teeth in between, so they mate together right here, and that's what we call a simple gear train. In comparison, when you have a gear where they share the same axle, and I apologize for my circle drawing ability today, but this example is what we call a compound gear train because these two, the green one and the yellow one, they share the same axle. So this is what we call a compound, and this is what we call a simple gear train. And they are not handled exactly the same. They're slightly different, and you'll kind of see how that works. We're going to spend some time on simples today, and you can catch one of my other videos for compound systems. Some people ask, why would you use a simple versus a compound gear train? A lot of times when you use a compound gear train, you're trying to get either up in gear ratio very quickly, or you're trying to get down in gear ratio very quickly. So it just depends on what you're trying to do. So in this case, what we're going to do is we're going to look at the equations. So we have four variables. So we have n is going to equal the number of teeth. You have d, which is diameter. You have w, which is speed or angular velocity. And then you have t, which is torque. And your formulas are going to look like this. So all of these formulas are going to equal gear ratio. So we have n out over n in. That's equal to diameter out over diameter in. That's equal to speed in. So take note of that one. That one's opposite. It's in over out instead of out over in. Speed out. And torque out over torque in. So those are our equations. And how do they work? Well, if you have one gear that is meshed to another one, and we'll say this has 30 teeth, and this guy has, let's say, 10 teeth, what we can do is we can do number of teeth out over number of teeth in. So one thing that you need to know is you need to know which one's the in, which one's your out. So for this example, we're just going to say the left one is our in. So when we're going to do 30 over 10, and we get a gear ratio of 3. Alright. Same thing goes for speed in over speed out, or torque out over torque in. You can do the same thing. If you're given two of them, or you're given two of them, you can find the gear ratio. One other thing you can do is you can, if you're given some more information, you can find something else. So let's say that this input had 100 RPM as our speed, and we wanted to know what is the speed of this one. So we could do that two ways. We could, now that we know that this is gear ratio, we can set gear ratio equal to speed in over speed out. So we could do our 3, and our speed in is the 100 over speed out right there. And this is one place that people usually, a lot of times they have a hard time with this for whatever reason. They want to multiply by 100. You can't touch that numerator at all. You're not allowed. So what we have to do is we have to multiply by, not 3. I don't know where I got 3. We're going to multiply both sides by W out. And what that's going to do is it's going to cancel it over here. We're going to put it over here. So now we have 3 W out equals 100. And then we're going to divide both sides by 3. So 100 divided by 3, we're going to get W out is a speed of 33.33 RPM. Now that's if you already know this. That's if you knew gear ratio. Alrighty, let's say you don't want to go through that step. What's one other way you can do it? Well, one way you can do it is you could just do N out over N in equals speed in over speed out. So we could do our N out, which is 30, our N in, which is 10, equals our speed in, which is our 100, divided by our speed out. And at this point, we're just going to cross multiply. So we're going to multiply across. So 100 times 10 is 1,000 equals 30 W out. Divide both sides by 30. And we're going to get 33.33 RPM equals W out. So it's all the same thing. It really doesn't matter which way you go. So either this process or this process right here. That works. No matter which way. No matter if you have teeth, diameter, speed, or torque. It doesn't matter what you have. You can find gear ratio first and then use it to find another one, or you can set them equal to each other like we did here. The teeth and the speed, you can set them equal to each other and solve it right out. There's not anything crazy to do there. And then the only other thing that you really have to pay attention to is when you have a simple gear train that has multiple gears, like more than 2. So let's say we have a gear train that's got, let's say it's got 4 on it. So let's say we have 1, 2, 3, 4. And let's say this is our in. And let's say this has 50 teeth, this has 100, this has 40, and let's say this has 20. Again, same basic process. Just use the same basic formula. So those are number of teeth, so N out over N in. Now what do you notice about this formula is nowhere on this formula does it mention about other gears. So this is your in, this is your out. These two are called idler gears. All they do is change direction. All they do is change the direction of the spin. So in calculation, they don't do anything. So just pretend like they don't exist in the calculation. On a simple gear train, they don't matter when you're talking about the actual gear ratio. So what we can do is we can just do N out over N in. So 20 over 50 And when you do 20 divided by 50, you get 0.4 is your gear ratio. You can write that 0.4 just by itself. You can write 0.4 to 1. You can put 0.4 over 1. It's all the same. Usually when I have you do it, when some of the other teachers have you do it, we're just going to ask you for the actual decimal. Maybe, every once in a while, we might ask you for the ratio. Maybe. But usually, we're just going to ask you for the decimal. Especially if you're doing things in Canvas and that kind of stuff. It's asking you to type in numbers. It's usually going to be just the decimal or the number that we're talking about. Alright, so that's simple gear trains in a nutshell, and that's the basics of the formulas. How to work them, how to use them, how to combine them, that kind of stuff. So take a look at my other videos for compound gear train, and it will give you an idea as to how to do those. Alright, thanks guys. Bye.